Welcome to a walkthrough of WEGAN's correlation tools for analyzing ecology data. WEGAN is a web-based platform for analyzing ecology data that requires no coding knowledge. In this step-by-step tutorial, we will show users how to use correlation analysis tools such as heat maps and regression. Let's begin.
Start by clicking the correlation module to explore multivariate data through heat maps and regressions. Next, upload your dataset using the Choose File button. Alternatively, users can use sample datasets. For this example, we will select the dune sample dataset on grass species in a meadow. Selecting the dune dataset will also load the accompanying environmental data. Click Submit to proceed with your chosen data file. The data integrity check page will confirm whether the data is usable, such as checking for correct sample and variable labeling. See our data uploading tutorial for more details on how to upload data and manage errors. Here, we see the dataset has passed the integrity check. Scrolling down, the data overview page will also display a PCA plot and heat map of your data. Click the Heat Map tab to see a heat map overview, as seen here. The Data Editor tab can be used to make slight adjustments to the data. Here, we can change the data type, edit the data, and remove entries. Find more details on our data uploading tutorial. Once ready to continue, scroll down and click Proceed. On the normalization page, you can select the normalization methods appropriate for your dataset. There are 4 manual data transformation options to choose from. Click a radio button to select a methodology. Click Manual Normalization to apply your own data normalization configurations. A pop-up will show you variable data distribution plots comparing the effect of your selections. In this example, no normalization was applied. To make revisions to the normalization, click Go Back. Going back, we can alternatively choose automatic normalization to apply recommended normalization settings based on Pearson mode skewness. For example, here are the distribution results of the automatic normalization. To move on from the normalization step, click Proceed. For ease of replication, this tutorial will continue with no normalizations. The second data integrity check page verifies data quality in the supplementary data. This page is for our environmental data. Here, we see our supplementary data has passed the integrity check. Click Proceed to continue. After completing data pre-processing, you can select the type of correlation analysis to perform. This example will begin with a correlation heat map. We have now reached the main analysis page. Here we can choose our desired plot and customize plot parameters. Start by adjusting the variables and parameters of the plot. For dimension, we can select either variables or samples. Display is limited to 1,000 variables. When displaying samples, more than 4 variables must be available for performing analysis. Next, you can adjust the heat map's color gradient. Select the statistical method to use for correlation. Options include Pearson R, Spearman rank, and Kendall rank. You can also select from 2 plot options. Click Update to apply changes. Scroll down to see your correlation heat map. Click on the Results banner to open a list of downloadable data files. Here we see the correlation data table and p-value correlation data table are available. Click either to download. Click Export to save your plot. Each unique plot should be exported using the Export button. Select the export format from a drop-down menu. We can select from PNG, TIFF, PDF, SVG, and PostScript files. Next, select your desired export resolution. Options range from 72 dpi to 600 dpi. Finally, select export size of either full page or half page. Click Submit to generate the export file. The download link will now update. Click it to open the export file in a new tab. Let's proceed with the second submodule, univariable linear correlation. The univariable linear regression submodule offers multiple analysis plot options via 3 tabs. The tabs are Model Assumptions, Line of Best Fit Plot, and Predicted versus Actual Plot. In the Model Assumptions tab, we can plot one of 4 assumption checks. As before, adjust the variables and parameters at the top of the page. Under Plot Type, we can select from 4 assumptions check options to plot, including QQ, Outliers, Posterior Predictive Check, and Homogeneity of Variance. Click Update to apply any changes. Scroll down to view your Model Assumptions plot. This example shows a QQ plot. Save your unique plot by clicking the Export button. Next, we can investigate the Line of Best Fit Plot tab. Adjust the variables and parameters as before. Click Update to apply your changes. Click on Customize Graph to modify the appearance of the plot. In the Graphics Center, you can first customize the plot style by showing grid lines or using the minimal plot theme. Next, select whether to display additional information on the plot, such as the equation, the R-squared value, and adjusted R-squared value. Choose whether or not to include 95% confidence intervals. Adjust the point and line colors of your plot. Click Update to apply your changes. Scroll down to see your updated univariable linear regression plot. This plot shows the correlation between the 2 selected variables. Lastly, we will proceed to the Predicted versus Actual Plot tab. Again, update the variables and customize the graph as needed. Click Update to apply your changes. Scroll down to see your actual versus predicted plot. Click on any file under the Results banner to download it. Next, we will look at the Polynomial Regression Analysis method. Select it from the left-hand menu. We are presented with the same 3 tabs as before, and can expect to see these tab options in most of the correlation module. We can adjust the dependent and independent variables, the polynomial degree up to 10, and the assumption check to plot. The assumption check options again include QQ, outliers, posterior predictive check, and homogeneity of variance. Click Update to apply changes. Scroll down to view your polynomial plot. Remember to save your plot by clicking the Export button. Download the polynomial regression data from the Results drop-down menu. Continue to the tab for Line of Best Fit Plot. Adjust the variables and parameters as needed. Click on Customize Graph and adjust plot display features such as style, labels, and colors as needed. Scroll down to view your polynomial regression plot with a line of best fit. Finally, continue to the Predicted versus Actual Plot tab. Adjust variables, parameters, and customization as before. Click on Customize Graph and adjust plot display features such as style, labels, and colors as needed. Scroll down to view your polynomial regression plot with a line of best fit. Finally, continue to the Predicted versus Actual Plot tab. Adjust variables, parameters, and customization as before. Scroll down to view the actual versus predicted polynomial regression plot. This plot compares the actual values to the values predicted by the polynomial equation of the specified degree. The line of best fit shows us how closely correlated the actual versus predicted values are. Let's move on to the multivariable linear correlation submodule. The multivariate regression submodule offers a change in tab options, presenting us with the relative importance plot. We will get to this later. As before, we select dependent and independent variables, whether to use normalized data and assumption type. Only numeric variables are used for building the model. Multiple independent variables can be selected. Click on Update to apply your changes. Scroll down to view your plot. The line of best fit indicates how closely the 2 variables are correlated. Next, continue to the Predicted versus Actual Plot tab. We can again select our parameters, including multiple independent variables. and can customize our graph's appearance and labels from the Customize Graph button. Scroll down to view the predicted versus actual plot. Finally, we move on to the Relative Importance Plot tab. This once again offers the same variable parameter and customization options. The Graphics Center now offers the option to display the R² label on the plot. Scroll down to see the relative importance bar graph comparing the selected independent variables. To save this plot, click the Export button as usual. Let's move on to the Logistic Regression submodule. First, we can adjust our variables and logistic plot parameters. Select either binomial or multinomial model type. The reference level of a categorical variable is analogous to its baseline observed value. The model results are relative to this value. The options for reference level therefore change depending on the dependent variable selected. For this example, the options are 1 through 5. Binned residuals is the only assumption check option available, so we will continue with that. Click Update to apply changes. Scroll down to view your binned residuals plot. The white area is considered within the error bounds. Dots presented in blue are within these bounds while red dots are outside. Download the related data files under the Results banner. Next, we can move on to the Effects Plot tab. First, we can adjust our variables and parameters. Notice that the reference level is also a parameter of this tab. Update to apply your changes. Scroll down to view the prediction probabilities plot based on the selected variables. Note that one plot is presented for each of the categories from our dependent variable with our reference level, 1, presented first. The customized graph options for this plot include color palette and whether to use non-normalized data. Next, we can move on to the ROC Curve Plot tab. Select the appropriate variables and parameters. After changing our dependent variable, notice that our reference level options have changed accordingly. The options are now hayfield, hay pasture, and pasture. Click Update to apply your changes. Our customized graph options for this plot include color palette and whether to use non-normalized data. Scroll down to view your ROC curve. The straight dotted line at 45 degrees shows prediction accuracy based on chance. Any lines above the dotted line perform better than random chance, while lines below perform worse. Next, we continue to the Penalized Regression submodule. In Penalized Regression, we first select the regression method, either ridge, elastic net, or lasso. Then we can select our dependent variable. All other variables will be considered independent. Click Update to apply your changes. Our customized graph options include plot style, wherein we can show grid lines or select minimal plot theme. Next, we can display the equation, R² value, and adjusted R² value. Then we can adjust the point and line color options. Click Update to apply any changes. Scroll down to view the predicted versus actual plot, which was trained on 70% of the data and tested on the other 30%. Continue to the Mean Squared Error Plot tab. Adjust the variables, parameters, and customization as before. Scrolling down, we see the MSE plot with log lambda on the x-axis against mean squared error on the y-axis. The gray region represents one standard error, SE, of uncertainty around each MSE estimate. The vertical dotted line represents the minimum MSE plus 1 SE. Continue to the SVM regression submodule. For the SVM regression, we can select one dependent and multiple independent variables. In the Customize Graph options, we can adjust colors. Select from two plot styling options. Choose whether to display the equation R² and adjusted R² values. Select whether or not to display RMSE metric, and adjust model metric sizing. Click Update to apply your changes. Scroll down to view the predicted versus actual plot. Download the SVM regression summary data file from under the Results banner. Proceed to the second last module, Random Forest Regression. Select the parameters. We can select multiple independent variables for this method. Click Update to apply your changes. In the Graphics Center, we can add labels, adjust the plot style, adjust the colors, and choose whether to display the 95% confidence intervals. Scroll down to see your predicted versus actual plot. The gray area represents the 95% confidence intervals. Continue to the Relative Importance Plot tab. Adjust the variables and parameters as needed. Click Update to apply changes. The customization options include whether to display an R-squared label on the plot. Scroll down to view the relative importance plot. Each independent variable selected will be displayed. Proceed to the Error versus Forest Size Plot tab. Adjust variables and customize graph as before. Scroll down to view your random forest regression plot. This plots the error rate against the number of trees in the random forest. Finally, we will proceed to the ANN regression submodule. Adjust the variables as needed. Artificial neural network regression only has one plotting tab. Note that there is an option to exclude independent variables from scaling. The dependent variable is by default normalized to a range of 0 to 1. You can customize the node colors, node spacing, and text sizing of your plot. Scroll down to view the ANN plot. Each variable selected becomes a starting node, seen here in pink. The thickness of each line represents the weight of that connection. Black lines are positive connections, while gray are negative connections. You can download the ANN regression data file under the Results banner. Access all data files from this analysis session through the Download option in the left-hand menu. Click Results to expand the list of files for download. A list of all data files from this analysis session will open. Click on any file to download. The download.zip file contains all listed files. Download the WEGAN Docker file to recreate the WEGAN coding environment. Download the R source file to get the exact R script used during your analysis session. After exporting your results, click Exit to return to the home page. We hope you found this tutorial on the correlation module helpful.